Hi guys, we still got our combo meal. This lesson is called Factor Algebraic Expressions, and when I was a kid and dinosaurs roamed the earth, we didn't call this factoring, we usually called it undistributing. Okay, so we didn't say, can you factor this? Can you undistribute? Okay, and really what it is we're doing the distributive property backwards. So instead of starting with this and getting this, we're gonna start with what's on the bottom and get it back to being what it started out as, like this. Okay. So basically the coefficient here is the number outside the parentheses. We're going to call that a coefficient. Don't worry about constant for right now. Factor, a factor is the number that divides another number with a remainder of 0. Okay, the greatest common factor, you've probably seen that before back in the day. And we're going to be using that. Okay, and then a prime number is a number with only two factors. Nothing divides it other than one in itself. So this is one of your practice problems. Let's take a look at it. It's item 3, and it says find the GCF. Okay, of this expression 45G plus 30H. Okay, and then one thing that they don't show in your lessons, which kind of bothers me because it's such a great tool and you probably used it at some time, is a factor tree. All right, so let me switch to green because this is a tree. A factor tree, what you can do is you can just split up a number. Think of a number that goes into it, okay, with no remainder. I'm thinking of 5 because it ends in a 5, right? 45. And then 5 times what would equal 45? 5, 10, 15, 20, 25, 30, 35, 40, 45. So 5 times 9. Okay, and then if you get to a prime number like 5, you can stop. You don't have to go like this 5, 1. That would be pointless. Okay, just stop when you get to the prime number. But 9 is not prime. I can divide that by 3. 3 times 3. Okay, so the prime factorization of 45 would be 5 times 3 times 3. Big whoop. Why do we do that? If we do it with the other number, it's going to help us. So let's make a tree for 30. I know 30 is 3 times 10. Okay, you could have started with 2 times 15. That would have been okay. Okay, then I can do 10. 3 is prime, so I can stop there. It's just 1 times 3. 10 I could break in half. That'd be 2 times 5. Now, the GCF. If I go through here and I find whatever numbers they both have. Okay, so let's see. They both have a 5 on the factor tree. And they both have 1, 3. 45 has 2 of them, but I can only circle what they both have. Okay. Whatever they both have. I forgot to write this. Let me just write this. So 2 times 3 times 5 would be the prime factorization of 30. But here the GCF, the greatest common factor, will be whatever they both have, which is 3 times 5, aka 15. Okay, so the GCF here would be 15. Okay, why do we need to find the GCF? Well, that's what we could undistribute. I could say that 45G plus 30H would have been, let's see, 15 times 3 is 45, so 3G plus 15 times 2 would get us 30. Hey! So there it is. We undistribute by finding the GCF, and that's our coefficient outside parentheses, and then whatever you have to multiply by. Let me show you where these numbers come from in the factor tree. Hey, check this out. This is cool. Let me get a different color. So remember these other numbers that we didn't use in the factor tree? Well, here they are, right there and there. Okay, so that's finding the GCF. In this problem, it just says find the GCF. This is one of your practices. So this one again was 15. Let's do another one. Let's see if they'll let us undistribute yet. Nope, find the GCF, and then on this last one I'm going to factor. Okay. All right, so again, find the GCF of 42m minus 28n. I'm going to do those factor trees again. These numbers are bigger, but that's okay. I'm not scared. Okay, 42, I know it's even, so I could divide by 2. Half of 40 would be 20, half of 2 would be 1. What goes into 21? Well, I know 3 goes into it. Did you know that if you add the digits of a number and you get a multiple of 3, then 3 goes into it? So 2 plus 1 is 3. That means I can divide this by 3 with no remainder. So 3 times what? 3, 6, 9, 12, 15, 18, 21. So that's 3 times 7. Oh, and I'm done. These are all prime numbers. Nothing goes into those except for 1 and the number. So this is the prime factorization of 42. Let's do this for 28. It's even, so I'll cut it in half first. Half of 20 is 10, half of 8 is 4, so 14. Let's cut that in half. That's going to be 2 times 7. So the prime factors of 28 are 2 times 2 times 7. Remember, the GCF is going to be whatever they both have. So they both have a 2. They both have a 7. Okay, here's the 2 and the 7 in the factor tree. Here's the 2 and the 7 here. So that means the GCF is going to be whatever 2 times 7 is. That's the GCF. All right, so that's going to be 14. And that's what I'll find here is 14. All right, now I finally get to undistribute. Okay. Okay. And I got to tell you guys, I learned this in 9th grade. Does that amaze you? You guys are so much smarter than we were back in the old days. You guys learned so much more stuff than we did. I didn't learn this till 9th grade, Algebra 1. Okay, 18m minus 24n. Okay, here's the deal. I'm going to want to put the GCF out here. Oh, not GF, GCF. Greatest common factor. Okay, inside here, I'm going to need something times m minus something times n. Oops, not m, n. How do I know that? Well, because, I mean, they're not going to have a common factor of m or n. If they were both x, I could factor out an x. Okay, but I can't do that. Okay, so I'm going to go ahead and make my factor trees. 18 is 2 times 9. 9 is 3 times 3. That's 2 times 3 times 3. Okay, let me do the factor tree for 24. That's 2 times 12. And 12 is 2 times 6. Oh, this is a big tree. 6 is 2 times 3, and I'm finally done. This one is 2 times 2 times 2 times 3. Let's highlight what they have in common. If you have highlighters, great. If you don't, you can just circle it. Let's see, they both have a 2. This one has 2 3s, but this guy only has 1. Okay, so here's the stuff they have in common, just a 2 and a 3. That tells me that the GCF is going to be 6. And now I already know what the answer is because this is a multiple guess problem. You see what I did there? But I'm just gonna keep going because it's not satisfying to me. So remember that what's gonna be inside the parentheses is anything we didn't use. Okay, so I know I'm gonna have 3m to get 18m. I'll show you that in a sec. And then 2 times 2 is 4, so it'll be minus 4n. Okay, that's the answer there. Here's how you can actually check your answer though. You can check it. You don't have to just, look and see if it's there and feel confident about it. You could actually mathematically check this by distributing. Okay, I know I've done my work correctly if I distribute and I get back what I started with, which is the 18m minus 24n. Okay, so now I have 6 times 3m. Okay, 6 groups of 3m's. That would be 18m's. Minus 6 groups of 4n's. 6 times 4 is 24. Hey, look at that! That's what I started with. Yay! It all checks out. Now I know I got it right. All right, guys. That's undistributing. Enjoy.